Welcome to Maths with EJD, another video on integration, and the focus now is on integration by substitution. Okay. Um, Talking about integration by substitution, right? Sometimes in order to integrate certain functions, we will have to make substitutions, right? So such substitutions can be algebraic or trigonometric. So in algebraic substitution, we replace an expression with an alphabet. On the other hand, an alphabet is replaced with a trigonometric ratio when we perform trigonometric substitution. So I'm going to make one video on algebraic substitution and another one on trigonometric substitution. So let's move on to talk about algebraic substitution. Of course, if you didn't know, algebra is simply replacing numbers with letters with letters of the alphabet, right? So that helps us to, it's a kind of representation for numbers. So that's what the kind of thing we are doing here. So straight to our first example, you want to evaluate integral of 9x plus 2 raised to power 6 dx. So, this looks like something you've done in differentiation. That's the idea of function of a function or chain rule. So if you want to evaluate that, right, it's always good to take whatever is in brackets. So, so you can take something like p equals 9x plus 2, such that if you differentiate that, you can see we are integrating, right? But differentiation is coming into it. And that's why I said if you do not really understand differentiation, integration would be a bit difficult for you. So you have to really go back to the differentiation videos and master these things. So here you have p to be 9x plus 2. So you have dp dx equals 9. And so that means that, what you have here is dx actually. So once you introduce something new into it, so you have to make sure that everything x before has to become p. So dp dx is 9. So that means dx has to be dp d9, dp over 9, right? That's if you turn it over, dp dx is 9. That means dx dp is 1 over 9. That means dx alone is dp over 9. So when next you see dx, you're going to replace it with dp over 9 because now you have introduced p into the story. So that means the integral of 9x plus 2 raised to power 6 dx is equal to, is equal to p, because 9x plus 2 now is p raised to power 6. So it's like you have found a way of simplifying it. So you have p raised to power x dp over 9. So I know dp over 9 is like 1 over 9 dp. So you can take out the 1 over 9 and you have p raised to power x dp. So this looks like a very simple thing to integrate now. It looks like a polynomial expression you can simply do. So p raised to power 6 would now be p raised to power 7 divided by 7 plus c. But never you forget that what you started with was not p. So once you integrate it, you have to take back what you did. So you have 1 over 9. So p raised to power 7 over 7 means that it's 1 over 9 times 1 over 7, and that is 1 over 63. And that's why you have 1 over 63 p raised to power 7 plus constant c. So you now you bring back your p. So you have 1 over 63, 9x plus 2, which you started with originally, raised to power 7 plus c, and that becomes the result. So this is integration by algebraic substitution. So you replace the whole expression with an alphabet, and that is an algebraic idea. So to evaluate this is what you end up getting. All right. So we have another example, which is a bit more complicated, but not beyond us for sure. So you want to evaluate. Now, this is actually now a definite integral. If you remember the idea of definite integral, once you have these limits, the expression, you're going to get a single value at the end of the day. You're going to get a number as your answer at the end of the day. So you have to evaluate the integral of x root 5x plus 2 delta x, dx, within the interval 1 to 8. So let's see. So to evaluate this expression now, so first of all, you have to take whatever is being covered up by a power or by a root, you have to take it out. So you say let p be 5x plus 2. So if p is 5x plus 2, right? So dx is what we had here. So to make things easier, you could actually say make x the subject of formula, right? Because you are now expressing x in terms of p. So if you make x the subject of formula, so you have p minus 2 divided by 5. So x is p minus 2 over 5. And then the p dx now, if you this is the same thing as Okay, so this is x first of all. Sorry, this is x first of all. Done. And then if you differentiate p with respect to x, the p dx will be 5, because if you differentiate p with respect to 5, you get 5. This is constant, so it goes. So the p dx itself is 5. So that simply means that dx is the p over 5. If the p dx is equal to 5 over 1, cross multiplying, you have 5 dx equals dp. So divide through by 5 like this. So dx is equal to 1 over 5 dp, or dp over 5 if you like. So that's why you have all of this expression right there. Okay, so then you now need to note should be taken that the integral limit will also change as follows. So you see, in this case, things are a bit more complicated because you actually have a set of limits. So beyond just doing what you did before, to say p is 5x plus 2, and then you make x the subject of formula based on that, and you also were able to get the p dx to be 5, such that dx is dp over 5. That means that wherever you find 5x plus 2, you're going to put p. Then, and this x2 has to be in terms of p, that's why we did this now. So you have p minus 2 over 5, because this expression is coming to replace this x here. But then this limit 2 should not be left out. So you have to transform them in the same way. And how do you do that? You use the same let p be a 5x plus 2. So you know that since p is 5x plus 2, at x equals 1, this is value of x because you are integrating with respect to x. So at x equals 1, so what do you get? You put 1 here. So you have 5 times 1. 5 plus 2, 7. So at x equals 1, that's p equals 7. Then at x equals 8, the one at the top, so you have 5 times 8, 40 plus 2, 42. So at x equals 1, you have p to be 7. At x equals 8, p is 42. So we can progress as follows. So integral of 1 over x into square root of 5x plus 2 dx from 1 to 8 has now been totally transformed, such that 1 becomes 7 in the realm of p, 8 becomes 42 in the realm of p. X here, is this guy. So we have p minus 2 over 5. And then this whole thing, this is p now. So this is square root of p. And the x on its own is actually the p over 5. All right. So that's a kind of transformation. Once you say the first statement, let something be equal to some expression. So it is going to affect every single thing you have. So everything comes into the realm of the new thing, whether it's p or anything you choose. So now we have all this. So you know that, of course, this is 1 over 5. This is 1 over 5. 1 over 5 times 1 over 5 is 1 over 25. So you take those ones out to make things easier for you to handle. So you have p minus 2 here left. Then square root of p is the same thing as p raised power half, which is easier to integrate. Then you have dp here because that 5 is gone out. So you have p times p raised power 1 over 2. That's more like p times p raised power 1 over 2. That's p raised power 1. And from indices, you have 1 plus half. That's 3 over 2. So that's why you have p raised power 3 over 2 minus 2 times p raised power half dp. So it's easier now to integrate these two because they look like polynomials. So we go to take care of that. Okay. So look at the integration. You have 1 over 25 here, of course, into covering everything. All right. So how do you integrate this? P raised power 3 over 2. That means you have 3, that will be 3 raised power, p raised power 3 over 2 plus 1. 3 over 2 plus 1 over 1. LCM is 2. 2 into 1 times 3, 3 plus 1 into 2, 2 times 1, 2. That's 5 over 2. Okay. So that's why this is p raised power 5 over 2. And you divide by the new power 5 over 2. And of course, that has to be from 7 to 42, like we have. Then, of course, this one has also been split apart. So it's from 7 to 42 again. So you have 2 outside here now. Then update this power. Half plus 1, that's 3 over 2. So you have p raised power 3 over 2 all over 3 over 2 from 7 to 42 once again. All right. So the next thing is, this is 5 over 2, right? So the 2 can go up and the 5 stays down. That's why you have 2p raised power 5 over 2 all over 5. Same here. The 2 goes up and 3 stays down. That's you dividing by 3 over 2. So you have 2p raised by 3 over 2 all over 3, of course, and you still have that from 7 to 42. Then the next thing is to take out these numbers. 2 over 5 can come out. 2 over 3 can come out. So you have 4 over 3. So that's 2 times 2 over 3. That's 4 over 3. And then you have only p raised by 5 over 2 into 7 to 42. So what is going to happen is you have p raised by 5 over 2 from 7 to 42. That means if you put 42, that's 42 raised to power 5 over 2 minus 7. I mean, yeah, if you put 7 now, minus 7 raised to power 5 over 2. So if you you have to, of course, compute this using calculator, like 42 raised to power 5 over 2. This is it here. 7 raised to power 5 over 2. This is it here. The same thing happens here. You have 42 raised to power 3 over 2 minus 7 raised to power 3 over 2. So if you punch your calculator and do all of these maths, you end up getting 167.3090. And that is the idea of definite integral. You end up getting a particular number, a value as your result, because it is integration within a specific interval. All right. So that looks a bit complicated, but then settle down and go through it. You'll surely make sense of it. Okay, so now we have to evaluate sine x. I mean, sine x raised to power 6. That is sine 6x. That means sine x times sine x in 6 places like that. Sine x times 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 sine x. So you can say it's like sine x all raised to power 6. That's the idea of that. And then you sine x raised to power 6 multiplied by cos x dx. Now, it is very important to note that sine x raised to power 6 is not the same thing as sine 6x. Actually, sine 6x is the same thing as sine x all raised to power 6. Extremely important to note that. All right. So that's the idea. So sine x all raised to power 6. So in that case, we have, since this is sine x all raised to power 6, so you can just say, you can already say anything that carries the power, that's what you should call your p, or you can call it u or v or anything. So you can also let p be sine x. So, and since immediately you just say p is sine x, automatically this dx will have to take a new name. So the p dx here will just be cos x. That means that the x alone, if you cross multiply, so dx cos x dx is dp. So that means that dx alone will be dp over cos x. So anywhere you see dx next, just replace it with dp over cos x. What else do we have? Okay, yeah, I mean, for cos x, you don't have to worry because you already have cos x and I will cancel it out. So you just come back and have integral sine x raised to power 6, that's p raised to power 6. The cos x that was there is still here. Then the x is dp over cos x. So cos x cancels cos x, makes life easy. So you can have this integral p raised to power 6 dp. So you can easily integrate that to be p raised to power 7 over 7 plus c. And that is 1 over 7 p raised to power 7 plus c. And what is p? You remember p, it was sine x. So that is 1 over 7 sine x all raised to power 7 plus c. And of course, sine x all raised to power 7 is the same thing as sine 7x plus c. So if you integrate sine 6x cos x dx, you get 1 over 7 sine 7x plus c easily. And with that, we come to the end of integration by algebraic substitution, where you say something to replace, a letter to replace a mathematical expression. Okay, so that's the end of that. So the next video will be on trigonometric substitution, so stay tuned. Thanks for listening. If you have not subscribed, be sure to do that and press the notification bell so you can always get all the videos. And mind you, watch out for the last video of integration. There you are going to have some general integration formulas and some exercise or practice questions to try your hands on. See you.